Hello, pre-algebra friends. We haven't done a flipped classroom in a little while, so I'm hoping that you'll be able to understand my explanation and be able to take these notes and come to class ready to do some problems without having to do much more on the lecture. This is 4.5, Rules of Exponents. We're just going to kind of march down our notes here. I think you're going to like what we come up with at the end of this section. It's going to make things a little bit simpler than the way we've been doing it up to date. So let's look at 2 to the 4th times 2 cubed. If I asked you to simplify this and do it by writing as repeated multiplication, we are going to basically, my word that you might remember from last week is unexponent, which I don't think is a word. We are going to unexponent 2 to the 4th and 2 to the 3rd and see what we have. 2 to the 4th is 2 times 2 times 2 times 2. So that takes care of that guy, times, and then 2 to the 3rd is 2 times 2 times 2. Now, if I rewrite this with an exponent, I put it all back together. How many 2's do I have? 1, 2, 3, 4, 5, 6, 7. 2 to the 7th is my answer. Let's do a couple more examples. 3 to the 1st is 3. Times 3 to the 4th is 3 times 3 times 3 times 3. And we write in exponential form is 3 to the 5th power. 5 squared is 5 times 5, 5 to the 4th. Here are my 4 5s all stretched out. Put it back together and I've got 2, 4, 6 of them. Let's do a couple algebraic ones with variables. X times X times X times X times X times X. Count them up. 1, 2, 3, 4, 5, 6, X to the 6th. And oh, here's a longer one. 1, 2, 3, 4 X's, 2 Y's, 3 more X's, and 1 Y on the end. Put them back together. X, and we have how many of them? 1, 2, 3, 4, 5, 6, 7. And we have Y as a base, and the exponent is 3. These are the answers. I'm hoping you're beginning to see the pattern by now. The question is, do we really need to stretch these out and write these like this? Or is there a rule that we can use to do it simpler, quicker, and without the chance of making a mistake? And the answer is yes. This is where we're going in this section. Let me get to the next page. And if you look on page 196 and 197 in your textbook, these properties, the product property and the quotient of powers property, are in green boxes, and you can copy down the form of way that the definition is. Basically, if the bases are the same, and you are multiplying, that's what product means, and you are multiplying, add the exponents, and you have your answer. The quotient we'll come back to in just a minute when we do the division piece. So some examples of the product of powers property that we just talked about. Your bases are the same. You're multiplying x to the 6th times x to the 9th. Your bases are both x. Write it down. Add your exponents. X to the 15th is your answer. Could that be any easier? This is y to the 1st, the ghostly 1, times y to the 7th. We're multiplying, the bases are both y, add the exponents, and y to the 8th is your answer. On this one, multiply your numbers together just like you would if this was all stretched out. If this was 3 times x times 5 times x times x, 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 5 times, you'd multiply the 3 and the 5 together and get 15, multiply x to the 1st times x to the 5th, and get x to the 6th. And that's your answer. On number 4, 20, and notice we have s cubed and y cubed. These bases are not the same. There is nothing you can do to combine them. So your answer remains 20s cubed y cubed, because our bases are different. Let's talk about the multiplying, the dividing piece now, the quotient. This is really a cool property. How we did this before, we in 4.4, we would have said, okay, we're looking for common factors between 24 and 52, and maybe we see, oh, what goes into both of those? I know 2 does, but I'm thinking 4 maybe goes in there, so that would be 4 times 6 over 4 times, and let's see, 52, I'll divide it by 4, and get 13. And then as far as the q's go, we would have stretched out this q to the 20th 20 times. We would have written q, and we would have written it 17 times on the bottom. That's a lot of q's. Very easy to make a mistake, and plus it's just too many to write. The quotient rule says that subtract, which is what would happen if we did it. Let's pretend like we're going to write these out 20 times. 20. So let's say there's 20 q's stretched out here. And down here, there's 17 q's stretched out. After we cross out the 17 down here, all of them crossed out, with 17 up here, how many are left? 3 are left. We took the 20, we subtracted 17. These 3 q's are left in the numerator. So our answer would be 6q cubed all over 13. And we get that by saying 20 minus 17 is 3. Let's do another. I see 36 and I see 14. I think 2 is the only thing I'm thinking that will go into that. That's 2 times 18, and that's 2 times 7. I see D is the same base in the numerator and denominator. I'm going to take 11 and subtract 8 from it, and that leaves D cubed in the numerator. 11 minus 8 is 3. And if you think about the D's all stretched out, going back to Q's again. If you think about the D's all stretched out, and there were 11 of them in the numerator, and there were 8 in the denominator, when we cancel out the 8 we have on the bottom, what's left? The 3 on the top. This guy right here. So we don't have to show all that stretched out mode. We can just do it with subtraction. The biggest mistake that students make is they write a D in the denominator. All those D's are gone. They've canceled out with somebody in the numerator. Let's keep going. You've got some, we're on the back side now, you've got some geometric figures. We're going to find the area of these figures, and we're going to use our quotient rule and our product rule. So I think the first one you have looks like this. One side is x, one side is x cubed. It's asking us to find area. Area of a rectangle is length times width. Area, the length is x, the width is x cubed. I've got like bases, I'm multiplying, so I can just add the exponents, and x to the 4th square units is my area. Number 8 is sort of similar. I think we have 3x squared and x. Again, it's a rectangle, length times width. 3x squared times x. Area is 3x to the 3rd. Don't forget, this is the ghostly one. Square units. I think I threw one more figure up at the tippy top. I'll do it up here. It's this triangle. Area of a triangle, 1/2 base times height. Area is 1/2. The base is 2x squared. The height is x. 1/2 times 2. 1/2 of 2. Think of meaning multiply. 1/2 of 2 is 1. X squared times x to the first is x cubed. So the area of this triangle is simply 1x cubed, or, of course, you don't have to say the 1. You can just say x cubed square units. Okay, a couple more. Now we're going to be doing both properties together. We're going to be doing the quotient rule and the product rule together. So we're looking at 22 and 4. I know 2 goes into both of those, so I'm going to write 2 times 11 and 2 times 2 for my numbers part. I've got a to the 9th and a squared. They're like bases, they're both a's, so I can use the quotient rule and say 9 minus 2 is 7. B and B, that's b to the ghostly 1. 10 minus 1 is b to the 9th. So all the variables leave the denominator, and our answer becomes 11 a to the 7th, b to the 9th, all over 2. Congratulations, you guys. This is Algebra 1 at its finest. And I know you're doing a good job. Let's see what else we have here. Okay. I'm going to write my numbers first. I see 3 and I see 6. So I can think of 6 as 3 times 2, and I see the 9 on the bottom. I can think of him as 3 times 3. We'll take care of them later. I see like bases on the top, and they're multiplied. So that's going to become y to the 6 plus 11, using the product rule, which is 17, over y to the 4th. The 3's will cancel nicely. And now I can still simplify further, because now I can use the quotient rule and say, my numerator and my denominator have the same base. So I can subtract. 17 minus 4 is 13. And my answer becomes 2y to the 13th. You can either put it over 1, or you can just leave it, because we don't have to write 1 when it's the denominator. So that becomes the answer. A couple more. This is all multiplication, no division now, so we're going to use the product rule. 3 times 6 is 18. C to the first times c to the third is c to the fourth. D to the first times d squared is d third. D cubed. That's your answer. This one looks hard. It looks weird. But it's really the same rule. When you think about it, all of my bases are alike. All of my bases are m's. And I'm multiplying. So the rule says that you add your exponents together. 3n plus 1 plus 4n minus 2 plus 3. These are my exponents. There's the first one, there's the second one, and here's the last one. Now I have to clean this up. I've got to collect my like terms. So I've got some n's here and n's here, 3 of them and 4 of them. That makes 7n. And I've got a plus 1 and a minus 2. That makes minus 1. And a minus 1 plus 3 is a plus 2. So this is my new exponent for m. So we have to write our answer as m to the 7n plus 2 power. Looks strange, I know, but I wanted you to see how easy it really was if you follow the same rule. Okay, a few more. So I'm asking you now, what would the question mark have to be to make the answer to this product w to the 9th power? Well, we know our rule says that you're going to add your exponents together, and that gives you your new exponent. So basically, I'm asking you 6 plus what will equal 9? Well, we know that the what has to be 3. So w to the 6th times w cubed is what will give us w to the 9th. 6 plus 3 is 9. This guy over here, what number would this have to be? Plus 9 to make 13. So what number plus 9 makes 13? And of course we know the answer is 4. So j to the 4th times j to the 9th gives you j to the 13th power. Let's do a couple with division. Remembering that we subtract our exponents. So what number minus 4 is going to give you 7? That's the question. So if we said that's x minus 4 equals 7, and we solve it mathematically, add 4 to both sides, you get x is equal to 11. 7 plus 4. So this question mark has to be 11. So the problem would look like this. b to the 11th divided by b to the 4th equals b to the 7th. Now more like this. So 12 minus what number is going to give you 8? Let's make an equation out of it. So subtract 12 from both sides. And we get minus x is equal to minus 4. But we know we want our x to be positive, so I'll multiply both sides by negative 1. And we get positive x is equal to positive 4. So 12 minus 4 gives you 8. So z to the 12th over z to the 4th gives you z to the 8th. And you can work those most likely without having to do any of the algebra work. I think there's 2 more. Let's multiply our numbers together first. 4 times 3 is 12, times 4 is 48. Y to the 1st times y to the 9th times y to the 5th. Add your exponents. 1 plus 9 is 10, plus 5 is 15. It's that simple. Let's do a little division. I'm going to think of 26 as 13 times 2. I've got x squared and x cubed here. This is interesting because if I subtract 2 from 3, I get minus 1. When you have a minus exponent, it's on the bottom. If you think about these 2 x's stretched out and the 3 x's on the bottom stretched out, when you cancel, 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 the 1 x that's left is in the denominator. Can't make my pen go up there exactly. There it is. So this x that's left is in the denominator. Y to the 35th, anything divided by himself is 1. He's gone. Then we have the 9. Oh, really, my pen is messed up on me. Let's see if I can go back and get it. The 9x is right here. The 13s will cancel. 13s will cancel. This x will cancel with this one. And my answer ends up being 18. And we'll do some more of these in class. Check the homework site, and I think most of you have written your homework down. Check that, and you'll be ready to go. Thank you. Have a good day.